Hey everyone, this is Vijay. In this episode, we are going to talk about building recommendation engines. A couple of years ago, my friend said, "You have to watch The Imitation Game about Alan Turing. I know you, and you'll like it." The question of whether I will enjoy a movie depends on quite a cornucopia of factors: plot, cast, screenplay, production, storytelling, etc. But my friend has presumably considered all these factors and predicted I will like this movie. If I watch it, quite possibly I will give a 5-star rating. If you think this premise is odd, consider this. The streaming services recommends a title to you every day. They predict how much you will enjoy a movie. For the same new unwatched title, you might get a 5-star recommendation and your spouse might get only a 2-star recommendation. How does it work? Let's double click into the details. Here we have 5 titles with 4 older movies: The Godfather, Space Odyssey, The Hunt of Red October, Fargo, and one relatively new movie, The Imitation Game. We have 4 users rating some of 5 movies. We are only considering binary rating, thumbs up or down. Of course, the third state is no rating, which means that user hasn't seen the movie or rated the movie. The 5th user is me. I have rated first 3 movies. I haven't rated Fargo, although it's my all-time favorite, and I haven't seen the last movie, The Imitation Game. The question is, based on my rating so far, will I like the movie or not? If we frame this problem this way, you'll be surprised by the number of people who get right solution to this problem. Let's do an intuitive pattern recognition here. My previous rating pattern matches with the rating of user 1 and 2 closely, and they have positively rated The Imitation Game. Interestingly, user 4 given inverse ratings as mine for first 3 movies and doesn't like The Imitation Game. Based on this, will I like this new movie? Our prediction will be resounding thumbs up. Remember, this rating prediction is customized for me and for this movie. For another user, it could be thumbs down. Let's zoom out for more movies. By this approach, we can predict my prospective rating for all the hundreds of thousands of movies in the catalog. That's quite impressive. Here we have expanded rating matrix with more entries, more titles, and more users. Using the same algo, we can fill in the blank cells with our own predictions. Like this. Now you know how your movie streaming company predicts the star rating for the movies you haven't seen yet. We can summarize our algorithm in 2 steps. First, we need to find similar users who have rated the item, that is the movie. We can employ k-nearest neighbor or KNN classification algorithm for this task. Step 2 is to aggregate rating from those users to predict a rating for a movie specific for one user. This whole approach we just discussed is under a body of algorithm called recommendation engines. Collaborative filtering is a group of algorithms which uses rating matrix, items cross user matrix, and the specific approach we discussed so far falls under user-based collaborative filtering. We have quite a number of algorithmic options to predict ratings or provide recommendations. Let's implement a recommendation engine using a real dataset with a blueprint. We want our model to use known ratings for a user, predict ratings for all the items tailored for the same user. That would be the output. We are going to build this model using machine learning, leveraging patterns from previously known ratings matrix, while using the underpinnings of KNN algorithm because we want to find similar users. If you want to know more about how KNN works, please check out 5 Minutes with Ingo video or classification chapter in my book. Time for actual implementation. All we need is a dataset. I'm going to use Movie Lens dataset. It has many flavors from 20 million ratings to 1K. I'm going to use a mid-sized dataset with about 100K ratings, thousands of users, and movies. One parameter, we need to specify K in KNN, and the data science tool. We're going to fire up RapidMiner. Let's find Movie Lens dataset. Type in Movie Lens dataset, new search engine, and the first link has the data. We're going to go with this 100K dataset. You can download it, and here is how the metadata looks like. U.data has the list of all the ratings, and u.item has the metadata about the movies. So please download these two files. I've downloaded these files and uploaded as movies dataset and ratings dataset. Let's have a look at how the files look like. Here you go. We have the rating dataset here. User ID is one column, movie ID, and the rating the user has provided for the movie, and the timestamp. We can ignore the timestamp in future process. And the metadata has movie ID, the title, and the genre. We have to join these two into one dataset. So we are going to use join operator. I'm going to use full inner join, joined by movie ID. Apply. Next up, we can ignore the timestamp. We don't really need that. So I'm going to use select attribute operator to ignore the timestamp. So I'm going to select single attribute, select timestamp, and we'll invert the whole selection. So all other attribute passes through except timestamp. Next, we need to let RapidMiner know what these attributes are. For example, the attribute rating is actually the label, and there are two special conditions we are going to use. Number one is user ID is actual user identification. Add one more entry. Movie ID is our item identification. So data is fully prepared now. We can use our modeling operator. Recommendation engine modeling operator are actually in extension. So go to your extensions marketplace and find recommendation and use the operator under recommenders, item rating prediction, collaborative filtering rating prediction, and user KNN. We're going to leave the default parameters for user KNN, the K is as 80, and we can use this as our modeling operator. We're going to use apply model. Apply rating prediction. So the model could be connected here. We can make use of the same data set for labeled test set as well. So I'm going to use split operator to divide between training and test dataset. Click OK, and this would be my test dataset. Let's connect all the output ports to the process output and run the process. Fantastic. This is our original dataset, this is a model, and this is our prediction. User 1 has rated this movie, The Fly, as 2.5 while we have predicted as 2.6. You can see all of these ratings are given by the user, and this is what we predicted. It's quite close. And the 4 ratings here, and we have close to 3.6 and 4.3, and 5 ratings here, and here we have 4.6. So the prediction is kind of working. We can measure the strength of prediction by performance parameters. So let's type in performance. And we are going to use performance rating prediction here. Connect the result set as an input, and we can get the performance vector. Run the process, and we get the performance vector on average, root mean, square error, of 0.9. If it is a pure guess, it'll be 2.5. So our model is better than the guess. Here we just built a recommendation engine using collaborative filtering. Thanks for listening.